So I'm going to set up this environment once again. So I will not give any explanation because this is already done. So quickly I can do it. So I'm selecting CentOS image and instance type. I'll take medium and 3 instances. I'll take. I'm going to allow all traffic.
Anna.
So this is the process I'm going to follow now. So I enabled all ports. Now I need to install all these commands. So quickly I need to install it. Okay, so these are the 3 machines. So let me name them. So first let me configure this machine. Anyone have this setup? Or you also deleted everything?
Don't have Praveen. I have deleted that once I practiced everything.
Okay.
Yes.
So for CentOS default is CentOS is the username. So done the configuration on the kernel master. So let me do it on the other machine. Actually, I forgot that I lost my AWS account. Otherwise, I could have done this today morning itself. Instead of doing, we can use Google Cloud also instead of doing this, but I'm not sure whether how it will work. So you guys try to install even COPS also, like how to set up Kubernetes cluster with the help of COPS also you can give a try. Different methods and you can note it down what is the difference with Kubedium, COPS. Okay, and we already had a discussion about that, but when you do practical, you can get more things to know. Okay, so now I need to execute this token command. Okay, I think it's added. It'll get notes. One node is added. It will take few seconds or 1 minute to get it online. So let me log into the another machine. Okay, so now it's done. This will take maybe 1 minute time to come online. The notes are ready. Uh, Now we talk about Prometheus. I think we need one more server where we can install Helm. Okay, so why we are going to use Helm? Because already we discussed in the previous sessions the purpose of Helm. You can sit in the remote machine. From there you can able to deploy the applications. So when we were discussing the course at that time, I was using the Jenkins server. Why? Because Jenkins server, we will configure the pipeline. Through that pipeline, it will deploy the applications inside the cluster. Okay, so here we created the cluster, and this is a Jenkins server, and inside this we configured Helm. So I hope you guys remember the Helm and Tiller concept. So this is the Helm, and here Tiller component will run any of the machine and any of the worker node. So when I execute Helm install and hyphen upgrade option, and I used to give the Helm chart which contains all the YAML files, whatever the resources are need to be created on the cluster, like deployment service like a node port or load balancer and HPA horizontal pod autoscaler, config maps. So these are the components. What are the components required for that specific microservice or application? Those related YAML files will be kept under the Helm chart, and that Helm chart we used to deploy from the Jenkins. So we have written the two different pipelines. If you remember, one is for CI job. Uh, Whenever the code check-in happens, then it will do the integration and it will create an artifact called jar file. And with the help of the jar file, it will create a Docker image, and that Docker image used to store inside the Nexus. That is CI complete. CD job, it will pick up the image, and it will use the Helm chart. Okay, and in the Helm command, we used to use that Helm chart and image we used to provide. Okay, then we able to install. So this here we used to use Helm. Why? Because Helm command will execute inside the shell of this Jenkins server in the pipeline whatever you configure. That's why we configured Helm and Tiller component, so that it will go and talk to the Tiller, and Tiller will take care of the deployment. That is what we have done. So now we don't need any Jenkins because I'm not configuring any CD job here, but I want this Helm and Tiller communication, so that now what I'm going to do, these charts are customized for our application. But already I told you there are some stable charts are available. Like if you want to configure EFK, Elasticsearch, Fluentd, and Kibana, like Prometheus. These we no need to create Helm charts manually. These charts are already providing by their vendors. Just you need to go to the stable repository, and from there you can get the charts. Everything is available based upon your requirement. You can modify it and you can use it. So to do that, I need a machine, or even if I have my local also, my local laptop also, if it is installed with Helm, then only thing is I need to initiate this tiller concept. Okay. For that also we had a document Helm and tiller configuration. For that we don't need any changes, because here we no need to, we are not configuring here uh, any Jenkins server, but in real time mostly we'll configure this Helm inside the Jenkins, because Jenkins will, when the pipeline executes, we'll define Helm command inside the pipeline. That's why to execute that Helm command, we install Jenkins server, Helm inside the Jenkins server. But as of now, I'm not configuring any CD job now. Just I want Helm command, so it can be any plain Linux server, or it can be on my Windows machine also. If I install Helm package inside my Windows machine, so here, if we are not taking any Jenkins, then take any normal user also in a Linux machine to that user give full permissions, and then install this Helm package. Okay, and after that, in the cluster we need to execute these commands. Why? Because this tiller component, these are like authority privileges. Okay, we are giving to the tiller, because when Helm is talking to tiller responsibility is to deploy the applications. Okay, so it should have control or access on the cluster. For that, we are creating one service account and we are creating a cluster role, so that this role contains full privileges. Then only tiller can able to install any kind of applications which is telling by the Helm. Okay, so these things we need to do it now. So first of all, we need to have one Linux machine. So already I think I have one Linux machine now, apart from our cluster. This is the Linux machine. Let me mention this and Helm. Okay, so let me log into this one. Okay, so here I'll try from directly root. No need to create user account. Okay, we'll see whether it will accept or not. So here I'm downloading Helm package, the curl command. It will be available in local, and then let me give execute permission, because it doesn't execute. It's a script, and already I told you, if we are using this means you want to install specific version. Why? Because sometimes, because a lot of times I faced while I'm doing practical in the real time, the compatibility of the latest version might be problem with your cluster. So you need to verify that first, which version of your Helm is compatible with which version of your Kubernetes cluster. So I installed 1.15, so that's the reason this is compatible, because sometimes you will not get proper output when you're using Helm commands. Okay, so again we need to test it, we need to open case, and then they'll get back to you that these versions are not compatible. So that's why you need to make sure which version we want to install. So this is how uh, will install. If you directly execute this one without these options, then it will install the latest version. So again, let me copy this. Helm installed. Now in the cluster, let me create this tiller. I think this is the master. Let me see nodes. Nodes are ready now. So creating service account. Executed. Yeah, okay. And now creating cluster role binding. Okay, these two commands on the um, cluster, and now I need to copy the config file. So config file from Kubernetes cluster to the Linux server where I am trying to install this Helm, so that then only when I execute this command, it will go and talk to the Kubernetes cluster, right? Otherwise, how it know we have a cluster and it should go and communicate? So to do that, we need to copy that file. So this was for Jenkins, that's why these all the steps. But for here, no need all these things. This is the one, the separate Linux server. I'll just create a directory called .cube and vi config. Inside that, I'll paste that content. Okay. So cat etc kubernetes admin.conf. Okay. Cat etc. This is the content. So I need to copy here from the master server and I'm going to paste it here. Okay. So that this root can able to execute from here also. I think we don't have kubectl here in this Linux machine, but it can able to access cluster now. Helm version, if you see. Hmm, okay, still now we did not enable the tiller. That's why it is giving error to show the version of the um, cluster. Okay, so now it is done. We need to execute this command helm init. So it will do initialization. So we have this config file inside this Linux machine. So it will go and talk to that machine and it will initialize. So before that, if you remember, inside this Kubernetes cluster, kubectl get pods -n cube system. Okay, actually the file where to whichever user account that file is copied, only that user account can able to execute kubectl commands because it sends API call. When you are executing command kubectl, what it will do, it will send an API call to the master. So to send that information, that admin.conf file copied as a config file inside the user directory called Praveen. So that's why he can able to execute. If you copy the same file to the root also, root can also able to execute this kubectl commands. Okay. So now kubectl get pods -n cube system. So here if you see, you don't see any tiller pod as of now. So now once I execute the command helm init command, then it will initialize and it will create a tiller deployment. It will do deployment. Okay. So from here, error connection refused. Okay. Why? Because I think here for this machine also, I need to enable all the ports. It will expect some ports to communicate. So from Kubernetes cluster to this machine, it needs to enable some ports. So instead of that, what I'll do for this Linux machine also, I'll enable all the ports. Now let me try again. Connection refused. We have dot cube. Where did I copy that config file? Okay, I did a mistake. I did not copy this config file inside this directory. So it is looking for config file inside this directory. I created outside of this directory. Okay. Now if I go to dot cube, it is available now. Okay. Now let me execute the same command helm init. It's done. Okay. Now if I type helm version, could not find a ready tiller pod. Why? Because it's getting deployed. Now if I go to the master server, See, tiller pod got deployed just 14 seconds ago. So what it is doing when you execute helm init tiller, then it's deploying a pod here. And even if you see kubectl get deploy and -n kube system, this was a deployment has been done. Okay, that's the reason it pod gets created. So now you can see it's up and running, and go to that Linux machine and again check the Helm version. Now it should show this way. It will connect to the cluster, and from the cluster also it should show the version. Okay, then only it's communicating with the cluster. Now from here we can able to connect. Okay, so this is like this Linux server which we created, and this is the cluster, and tiller got deployed, and here I installed Helm. That's done. Now why we are making a range of this, because now to install the Prometheus. Okay, so now setup is ready. Now we talk about the Prometheus. So what is the purpose of Prometheus now? So Prometheus, see, before this cloud, whoever worked as an Linux administrator, Windows administrator, they might know there was an monitoring. Okay, infrastructure monitoring, like how much, if you have a data center, inside your data center you have hundreds of servers, who is going to monitor that, whether which server is down, which server is up, what is the file system usage, and how much CPU it is using, how much RAM it is using, and if it is a CPU is using more utilization, then how we come to know. All this monitoring was done by some tools. It's a paid tools are there, and free tools are also there. Like one of the tool is called Nagios, is a free tool, and paid tools are like SolarWinds, HPO, IBM tools. Lot of tools are available in the market. Each company will purchase those licensing, and they will install the tools on some servers. Let's say Windows Server 2016 or 19, and they'll install that software. And inside that software, they will configure all your servers information. What is the IP of this server? Whether it's a prod or test or development, and file systems, CPU utilization. They used to install some client software inside this machine so that they can able to communicate to this machine. Okay, so these tools will monitor whenever if any server is down or any file system. Let's say Windows D drive is 90%. Then it will, this tools team used to configure the alerts. What alerts? So it will trigger an email. If you configure, it is monitoring, but how the tools team will come to know, they will configure an alerts. Okay, so if it is a Unix server, they will configure Unix team distribution list, and their team DL also. So once you get the alerts, based on that, there will be separate ticketing team will be there, or monitoring team itself will be there. They will create a ticket for you based upon the alert. If you get production server down alert, so they will check if it is real alert or not, and it depends again each organization. So if it is real alert, then they will create a ticket and they will assign to respective team. If it is Unix team will get alert, and if it is database team, if database tables are having any problem, database is down or database server is down, database team will also get alerts. Like this, respective team will get alerts. Network team will get network switches, routers down. Storage team will get storage related alerts. So this everything is monitoring is very very important. Then you can take action immediately. Based on that, tickets will get raised, and we'll work on the tickets. If production server is down, then you need to react immediately. If it is really down, if it is really down, then how quickly you can resolve it. So this is called monitoring. As I said, Nagios is a free tool. SolarWinds, HPO, lot of tools are there. We'll monitor it. The same thing, we need to monitor our Kubernetes cluster also. What are the worker nodes are there? Okay, and what are the pods getting created for each pod? How much utilization is happening, right? And file systems, everything, lot of things. Even in your applications API, also you can monitor. So all this to monitor, we are going to use Prometheus. So why can't we use Nagios or SolarWinds? Why? Because our Kubernetes cluster is a dynamic environment. So what is dynamic environment here? Pods are getting created and pods are getting deleted. Again, pods will newly gets created, right? In previous scenario which I explained, in the traditional data center, the virtual machines are fixed. Once you create virtual machines, when you create physical machines, those IPs will be fixed. Okay, those servers will be always available. It's like a static. But here, pods automatically sometimes gets created, deleted, new pod gets created, right? So they are dynamic. So you cannot configure any specific pod name or pod IPs in the configuration. So Prometheus will take care of it, and it will collect all the logs, and it will give you in the dashboard. Okay. So to do that, uh, what we need to do, same like EFK only, like what it is going to do, Prometheus, when you install this, it will deploy some pods related to the Prometheus, and it will collect all the information of the pods from this worker node, and it will send it to the another server, okay, which we call as a Prometheus server. So when we deploy this Prometheus application, it will create multiple pods, okay, Prometheus server, and Prometheus alert manager, and Prometheus exporter. So these are different kinds of pods gets created. So exporters means what? Here exporter pods will create how many nodes you have. In each node, exporter pod will create, and that will export the data information metrics from this worker node to the Prometheus server. This also might be running somewhere inside the same worker nodes. This Prometheus server also might be assumed this is running here. So these exporter pods will send that information to here, and to the Prometheus server, and we can able to access this Prometheus server also. Okay, and this alert manager means if you want to configure alert manager, just now I discussed. If you want to get in notification, then you can configure alert manager. So all these things will get deployed when you deploy Prometheus. And how you can view this? With the help of Grafana. So we have a separate, you need to install separate Grafana. So when you install Grafana, you will get created with service also, like load balancer or notepad, whatever you define inside the file. So with the help of Grafana, we can able to access the dashboard, and inside the dashboard, we are going to give data source. So what is the data source? Prometheus is the data source. So we'll give Prometheus a data source and give this IP of this Prometheus. So it will collect all this information from this Prometheus graph server to this Grafana. So visualize, for visual purpose, we are going to use Grafana dashboard to see what are the logs of this metrics logs of the Prometheus. So we can see everything whatever is configured, and you can configure a lot of metrics also later on. It's up to us. Okay. So we need to install Prometheus and Grafana now. So now that's why we install this. Why? Because we have a Prometheus uh, stable version is there, Helm charts, but we can use that Helm chart, and we can do a little bit of modification from our end, and we can deploy this Prometheus inside these missions. Okay, so now let's go and I will show you. So as I said, in the stable um, repository, you can able to find the Prometheus Helm charts. So if you see here, already I told you this is the values.yaml file, where you can see all the variables are placed under this values.yaml file, and inside these templates you can see these are the resources are going to get created. If you see, these many resources are going to get created. Daemon sets is there, deployment is there, persistent volume claims is there. Okay, lot of components are going to be created, config maps, stateful sets. Vertical pod autoscaler is also is available. Okay, so we are going to deploy this, but before that, what I am going to do, we will go through this values.yaml file. So it expects some volumes. Why? Because see, all the collection of the data, it need to store somewhere, so we need volumes. We already discussed volumes like mtdir, host path, what is pv, physical volume, what is physical volume claim, also we discussed. In real time we use physical volume and physical volume claim, because this is the persistent data we need it. Because if all of a sudden, if your let's say this Prometheus server pod has been restarted or deleted, then it will delete the volume and it will get the new volume. So whatever the data was available, the data will be lost. So whatever the logs was sending by this exporter to your Prometheus server, the data will not be available. So that's why in real time we use physical volume and physical volume claims, so the data will be persistent available. Okay, so that you can practice. But here I'm not going to use any persistent volumes. I'm going to use mtdr only by default. Okay, so it will create in locally for temporary purpose to practice. When you delete the pod, the data will also get deleted. So here if you go to the values.yaml file, here this is all the configuration for Prometheus, like alert manager, push gateway, all these things will be available. I need to do little bit of modification. Why? Because I will show you here. Type so if you see here, type is showing cluster IP. This is for alert manager. Okay, so for alert manager, we don't want our type should be node port or load balancer, but the server, whatever I'm talking about, this server, because when Grafana is trying to access Prometheus, it should be accessible from the outside. So that's why we need to give uh, this is for alert manager service. Okay, you know, right? Services, load balancer, node port, and cluster IP. So when we deploy Prometheus, it will create 3 to 4 services. One is for alert manager, one is for Prometheus server, one is for gateway. So another one is, this is for exporter. Even we don't want a node port or load balancer for exporter. If you remember, cluster IP means what? Internal communication in the cluster, inside that one only. Node port means what? From outside also we can able to access it. Okay, so we want not for node exporter. So let me search again. So this is the one. If you see list of IP addresses at which the Prometheus server service available, for this I need to change it. Okay, so this I need to change. So how I can change? No need to worry. So here in this Linux machine where I installed Helm, so we can just do Helm repo list. So if you see here, Kubernetes chart.storage. This is a default stable repo, means it will connect to this repositories. Okay, so now Helm search Prometheus. So these many Helm charts are available. It connected to this stable repo, and it is showing this one. And this is the one we are talking about, stable Prometheus. And this is the chart version. Okay, Prometheus is a monitoring system and time. Okay, so now I'm going to use this one. But what I'm going to do, we have a command called Helm inspect. Okay, so I'm going to view values.yaml file, means I no need to clone locally to view the values.yaml file. With this command, without having this Prometheus Helm chart into my local, still I can able to see file of that Prometheus Helm chart. So now what I'm going to do, I'm going to view the values file. Okay, stable Prometheus. If you execute this, it will display. It's like a cat command. Okay, no need to have cat command. The file should be available locally, but this no need to have locally. So it will connect to that stable repo Prometheus Helm chart, and it will give you the output of the values.yaml file. And that what I'm going to do, that output I'm going to redirect it to some other file. Okay, /tmp /prometheus dot values. Okay, I'm redirecting that information to this file, whatever the output is going to come. It's done. Now if you see /tmp, why tab is not working? Okay, so this is a file, and if you can see, this is the values.yaml file. So here I need to do that update, the type. Okay, so I will open this file, and I'll search with type. So here type cluster, but we need to be very careful, like this is for alert manager. If you see, this is for alert manager, so I don't want this. And this is for node exporter. If you see here, node exporter, even I don't want for this one. And this is for Prometheus server. Okay, so here I would like to change it, and here we need to give node port. Okay, and we need to give port, node port 32323, something like this. So we need to give 32,000 to 32,000, some range is there. Inside that only we need to give the port range. So I'm giving this node port. Okay, so now apart from this, and let me search persistent volume. If you see here, persistent volume, by default this is false. If you make it true, then we'll create a persistent volume claim. So if persistent volume it is trying to create, then it should have persistent volume also, right? So if you remember the PVC concept, so first it will be PV, and it will be PVC, and this PVC we can use inside a deployment file. Okay, so now we don't have any PVCs now. Why? Because this is a fresh installation. If you remember NFS dynamic provisioner, if you have that, then automatically your Prometheus will create physical volume claims, and it will use by the pods. If but you need to enable true here. If you enable true here, then it will expect persistent volume claim. If you don't enable, then it is using MTDR. So I'm going with this by default as of now. Okay, so MTDR automatically it will create. So I'm not changing anything. So this persistent volume, it is available in multiple places, I think so. Okay, and persistent volume, if true, Prometheus will create a user. If false, so let me make it as false here. Okay, so here you change it wherever persistent volume it is showing true, and So here also it is there. So just make it false. Okay, I think all the three places, like for alert manager, for node exporter, and for Prometheus server, we change it to the false. Okay, now that's it. These changes we need to done, and once it is done, save this file. Once this is saved, this is in the local. Now Helm chart is in the stable location. Okay, in the repo. Now I would like to install that by using this values.yaml file. I don't want to use the default values.yaml file, which is going to get from the Helm charts. So for that, help install stable Prometheus. Now hyphen name. Give this release name. What is the release name you want to give? This is the release name, and hyphen values. Now I'm telling that use these values. Okay, so I'm declaring from here so that it is using this. If you don't give these values, then it will take directly from the default values.yaml file from here. But I am giving this hyphen values, telling that use this values.yaml file. And apart from this, I'm going to give different namespace. I don't want to install it on the default namespace, as already told you when we talked about namespace class. So we don't want to create all the resources in the same default namespace. If you install Prometheus in different namespace, then it will be easy to filter, right? Whenever I want to go and see Prometheus related stuff, I can go and see in the separate namespace. If all the pods are in the same default, then it will messed up. Grafana, Prometheus, EFK, application, everything is showing in the default namespace. Then all will be mixed and will be difficult to manage them. So that's why I would like to install it, deploy it on the separate namespace. So now let me execute this one. Failed service is invalid, spec type, unsupported value, node port, supported values, cluster IP. Okay, I missed n caps I should give. I gave in this way. Okay, okay. Here I need to give in uppercase N. Okay, so Helm list, if you see, it is when I executed first time, it is in the failed state. So again, I'm trying to with the same release name. It is telling it's already exists. So I need to delete this Helm delete this release name purge. Now again, I'll do that. Okay, it's deployed. You see what are the resources it got deployed, everything it will show here in this deployment. See, the name is release name and namespace is Prometheus. Config maps it got deployed, 2 config maps, and daemon set. This is deployment. If you remember when we talk about the deployment types, stateful set, daemon set. So one daemon set, if you remember the purpose of daemon set, I'm not sure whether you remember or not. Exporter is deployed with the daemon set, and these are deployments, and these many pods got getting created, and these are the services. If you see, these are the services: alert manager, static metrics, node exporter, push gateway, and this is the server. This is I gave node port. That's why it's created node port 32323. Okay. And these are the service accounts got created, cluster role binding. Why? Because it should have the access to the cluster, because it is pulling the information metrics resources, right? So that's why it should have a role. Otherwise, it cannot able to access the cluster and get the information, right? So that's why if you see here, nodes deprecated and moved to this location. Prometheus server can be accessed by port 80 on the following. So you can able to access this to get the latest version of Helm charts, I think so. Deprecated means it's not supported or it's expired version. Okay, you can see here maybe the latest one. If you see 9 days ago, 3 days ago, community Kubernetes Helm charts. So now if I go to the master, when I type kubectl get pods, it will not show. Because why it is not showing? Why the pods are not showing here? Why the pods are not showing? Why it is not showing? No one knows why it is not showing.
You need to create a namespace.
Not
Hmm?
Namespace.
Namespace? Just now I told you, right? It is in the different namespace. When you type this, it is will be in the default namespace. So you should go and check in the -n Prometheus. So you should check in the different namespace, means wherever you deployed. Okay, so these are gets deployed here. kubectl get all -n uh, -n Prometheus. This will show you what all means what, whatever the components got deployed inside this Prometheus namespace, it will show everything. So these many components got deployed: pods, service, daemon sets, deployments. Okay. So here if you see, this is alert manager, pod is running, and node exporter. As I said, node exporter means what? E- Each pod will go and deploy in each worker node, and it will collect the information and it will send it to the server. Okay, Prometheus server, right? And alert manager, I'm not going to show you how to configure alert manager, all these things. You can do an R&D, okay, later on when you are familiar with all the Kubernetes concepts. So you can configure alert manager also, it will send an alert. And these are the services. So all our cluster IPs, only I configured Prometheus server as a node port, okay. So this is what I configured. And so these are deployments, whatever the deployment. So if you want to access 32323, I can able to access by taking the any of the node IP. Okay. Take any worker node, IP. So this is Prometheus server which we can able to access, but we don't need this one. We are not going to do anything here. So this will be given into the Grafana. So what I am going to do, so we'll continue on Monday, it's the same time, 8 o'clock or 8:15, 8:15 just because AWS class will be going on. It will complete at 8:15. So if you guys join on Monday, then I'll show you installing Grafana and how to add data source in the Grafana so that it will connect to this Prometheus. And from the Grafana dashboard, how we can see uh, the dashboard, okay, how we can see the metrics, all these things will show you on the Monday with the remaining part, okay.